Okay, so the next thing that we're going to talk about is collision theory of reaction rate. Chemical reactions occur when atoms, ions, or molecules collide and produce different substances. So something that we need to talk about is that chemical reactions only occur if collisions occur. And collisions are totally random. So particles are moving all over gas and in liquids and solids, and the chances of those particles colliding is completely random. All right? So the rate of a reaction is determined by the rate of effective collision. So in order for that chemical reaction to occur, not only does the collision have to occur, it has to be an effective collision. So the rate of effective collisions is going to be influenced by 6 different factors. The 6 factors are the nature of the reactants, the orientation, the concentration, the temperature, the surface area, and the catalysts. So basically for catalysts, if we're going to be adding a catalyst or not. Okay, so the first one's the nature of the reactants. Reactants that require less changes in bonds react quicker. So here I have up an example. So say if we were using hydrogen to react with oxygen to form water. Here we have 2 bonds that we'd have to break in order to form 2 completely new bonds. So basically, the less bonds that you have to break or form means the faster the reaction. Also, choosing a different type of reaction, that could increase your reaction rate as well. Okay, so orientation, that's talking about the way that the particles are facing. So reacting particles must be lined up correctly in order to react. So let's look at these 2 reactants right here. Here's a particle, and here's a particle. These 2 are lined up correctly, so the particle can react with the particle, and this bond and this other particle can react together. So this would form an effective collision for a reaction. If we look over here, we have 2 particles. These 2 particles can react, but now these cannot that are attached to it. So if it's not lined up correctly, they're just going to bounce off each other, and there's not going to be a reaction. Alright, so the next factor is our concentration. So an increase in the amount of particles increases the chance of collisions. So what I want you to think about is if you are walking around the state fair, there are a ton of people there. So when you have a lot of people, how often do you bump into someone that is walking around the state fair? You probably bump into a lot of people since there's so many people moving around in a small area. But then if you're on like a farm someplace or in a cornfield, there are not that many people that are over there. So the chances of you running into someone are a lot slimmer. Same things happen with particles. So here in this box, we only have 5 particles. So the chances of these particles running into each other are a lot less than in this box that has a whole bunch of particles in it. Another example for this is looking at air and oxygen. Okay, so if you had a campfire and you wanted to light the wood on fire, obviously, if it's a campfire, you need to have oxygen in the air for that fire to burn. If we were to put that campfire in pure oxygen, so the only thing in that air was oxygen, it would burn so much faster because you have all those oxygen particles to react with the wood in order to burn it. In air, oxygen is only a percentage of that air. So it would take longer to burn in air than it would in oxygen. Alright, so the next factor here is temperature. Increasing temperature increases the speed of particles, so temperature is your average kinetic energy. And also, if you increase temperature, the particles each have more energy, and they're able to get over the activation barrier easier. So let's think about temperature for a little while. If you're in a low temperature, particles are moving slower. When you increase temperature, those particles gain energy, so they're able to move faster. So at low temp, these particles are not moving very fast. So if you're moving slower, the chances of you hitting into someone else or something else is going to be less likely. In a higher temperature, those particles have enough energy to move quickly. So the chances of these particles hitting something else are a lot more likely since they're moving faster all over the place. surface area. By increasing the surface area, you're allowing for more possible sites for collision. Okay, so let's look at this box right here. There's only a few different sides that these particles can collide with. Here, I broke the box, so it's the same volume, up into just smaller pieces. Alright, so now I have the same amount of particles, but there are so many more sites for those particles to hit. So here I had only 6 sites, and now I have 6 times 6, so that's 36 different sides for those particles to hit. Alright, the last one is a catalyst. So a catalyst lowers your activation energy so that more particles will have enough energy required for an effective collision. Okay, so in order for a chemical reaction to occur, not only do particles have to collide, but they have to have enough energy in order to collide. So if we add a catalyst, the amount of energy that those particles needs will be lower. So now instead of having to go all the way up and around on this green line right here, they only have to go on this dotted red line. So instead of going all the way up, they can take this shortcut right here and still get down to the reactants. Get down to the products.